So what we have here are two parallel lines cut by transversal. Things to remember, parallel lines cannot be assumed. They must be either proven to be parallel or you must be told they're parallel. In this specific problem, I'm told they're parallel by the markings. So this little arrow here and here on the line itself, so a bold arrow is going to demonstrate parallel lines. So we have here parallel lines cut by transversal, so a little vocabulary for you. In general, any two lines that are intersected by a third line, that third line is called a transversal. The only place it really has any mathematical effect, though, is in parallel line problems. So this green line right here is a transversal that intersects the two parallel lines. And as you can see from the picture, it creates 8 distinct angles that we're looking at. And what I want to consider for these is we have these angle pairs that they call them. And things that have some common relationship is basically what it is. And each of these has words that describe them, and the words that describe them help you to establish what they are. So let's just take a look at the words that describe them and then use that to figure out. So if I see the word alternate, it's alternate on both of those, and I've got a transversal, all right, the green line there cuts things. Some of those angles are on the left side of the green line, some of them are on the right side of the green line. When I say the word alternate, alternate usually means changing. Alternate means on opposite sides of the green line, opposite sides transversal. And then you got the word interior and exterior. Okay, interior angles are all the angles inside the parallel lines. And exterior angles are all the angles outside the parallel lines. So when I say the word alternate interior angles, I'm focusing on the blue highlighted angles, and I want the angles on the opposite sides of the transversal. That's how we're describing alternate interior. So I'm seeing that 3, 4, 5, and 6 are all interior angles, 3 and 6 are on opposite sides. So angle 3 and angle 6 is one angle pair. We'll separate the angle pairs with semicolons. And the second angle pair that is described by alternate interior angles will be angle 4 and angle 5. Again, they're both interior angles, they're both on opposite sides of the transversal. Okay. I will be using these words to describe angles, so as we're doing this, a lot of geometry has to do with terminology, definitions, things like that. So as a teacher, I can use words that you guys as students know what the words mean, and we can have a very clear understanding of what everything is in the class. So that's what alternate interior angles are. Alternate exterior, same idea, except now we're dealing with the exterior angles. So 1 and 2 and 7 and 8 are all exterior angles. They're all outside the parallel lines. And on alternate sides, opposite sides, 1 and 8 would be alternate exterior. And 2 and 7 would be alternate exterior. Oops. So those angle pairs exist. Now, one thing I'm going to tell you real quick while we're doing this is alternate interior angles are congruent. Alternate exterior angles are congruent. That represents two theorems in the chapter, the alternate interior angle theorem, the alternate exterior angle theorem. All right. So, those things you want to know. As far as if-thens are concerned, if two angles are alternate interior angles, then those two angles are congruent. If they're congruent, they're also equal in measure, right? Which means if 3 is 60 degrees, 6 is 60 degrees. If 5 is 120 degrees, 4 is 120 degrees. Right? So They have the same measure. Congruent means they have the same, they're the same size, same angle. All right. The next word we have is corresponding. And the best way for me to describe corresponding to you, it goes like this. Let's use purple. All right. Imagine there's a point right here at the intersection of the transversal and the parallel line, and a point right here. And I was describing somewhere to somebody the position of angles in relation to those 2 points. If I give the same description, those angles are corresponding angles. So, looking at angle 1 is to the left and above the point. Angle 5 is to the left and above the point. Right? So we're given the same description to describe angle 1 and angle 5. They correspond. Right? That's the idea of corresponding angles. So angle 1 and angle 5. If I continue along with that same idea, another pair of angles where I'd have a similar description to find those angles, again starting from the point, the purple point here and the purple point there. If I go to the right and up for both of those, I get angle 2 and angle 6. If I start at each of the purple points, go left and down, I'm hitting 3 and 7. And finally, if I go to the right and down, I'm hitting 4 and 6.
4 and 8.
Oh, 8, thank you, 4 and 8. My bad. Right and down, 4 and 8. The 4 and 6 have the same color. My eyes tricked me there. So yeah, 4 and 8 would be corresponding. So corresponding angles, that's where they are. And again, left and above, right and above, left and below, right and below. And the property associated with corresponding angles is corresponding angles are congruent. The final type of angle pair that we talk about are consecutive interior. The book calls them same side interior. I've always used consecutive interior, and I wasn't reading the book when I wrote this slide up. But if you want to either say same side interior, what the book says, that's how they're going to describe it in the homework assignments, or consecutive interior. It does say interior, so I do know it's talking about angles 3, 4, 5, and 6. Alternate bed on opposite sides of the transversal. What do you think consecutive means?
Same side.
Same side, right? So same side interior, same side of the transversal. So if I'm talking about the interior angles on the same side, we're talking about 3 and 5 on the left of the transversal and 4 and 6 on the right of the transversal. So angle 3 and angle 5. And the other pair is angle 4 and angle 6. Do 3 and 5 look equal?
No.
No.
Okay, so there's a different property associated with this. Everything else, they're all congruent. This one is that consecutive interior angles are supplementary. They add up to 180. So the nice thing about this, all these properties, is as soon as you know one angle measure in this picture, you know them all. I'll demonstrate real quick. Suppose that angle 4 is 110 degrees. How big is angle 2?
110, it'd be 70.
It'd be 70, right? Because that's a straight line. Those two angles make the straight line. We have straight lines in the picture, right? So if you have two angles making a straight line, they're a linear pair. If they're a linear pair, they add up to 180. 110 and 70 makes 180. Angle 2 is congruent to angle 3 because they're vertical angles. Angle 3 and angle 7 are corresponding angles. Angle 3 and angle 6 are alternate interior angles. Also, angle 2 and 6 are corresponding angles. 4 and 5 are alternate interior angles, same. Vertical angles, same. Vertical angles, same. So once you know any angle measure, you can find all the angle measures in that picture. It's just a nice little way to do that. These are actually the names, and the purpose of the names is for vocabulary purposes, so when I describe something, you know what it is. The easy way to understand all the facts about this, if I'm just trying to find missing sides, all the acute angles have the same measure, all the obtuse angles have the same measure, every acute and obtuse adds up to 180. Okay, so again, there's 8 angles, 4 measures of one, 4 measures of the other. The 4 small ones are the same, the 4 big ones are the same, any small and big makes 180. But again, for the purpose of vocabulary, know these words, know what they mean, so when I describe things, you know what I'm talking